In this warm-up, you are going to determine whether the triangle is a right triangle by writing the words yes or no for each one. We're going to read a story about a boy named Pythagoras. Long ago in ancient Greece, there lived a curious boy named Pythagoras. Pythagoras just couldn't help poking his nose into places. Sometimes his curiosity got him in trouble, but sometimes it paid off. One day Pythagoras sat in the shade of an old olive tree. He could see the harbor and the sparkling blue sea around the island where he lived. Nearby, two workmen were building a temple. They began to argue. "This ladder is too short to reach the roof," Pepros grumbled. "That's not possible," said Saltos. "The wall is 12 feet tall, so I made the ladder 12 feet long." Pepros roared. "The ladder only reaches the roof when it's flat against the wall, and then no one can climb it. This is as bad as the columns on the porch." Pythagoras poked his head out from behind the tree. "What's wrong with the columns?" he asked. Pepros frowned. "It's that pesky Pythagoras again. Stop bothering us. At this rate, we'll never finish the temple." As the workmen argued, Pythagoras crept around to the other side of the building. 4 columns stood on crooked bases. Some columns leaned to the left, others tilted to the right. "These columns will never hold up a roof," Pythagoras said to himself. "I wish there were something I could do to help." Still thinking about the problem, he ran home for dinner. How would you make the columns stand straight? In today's construction, we have a tool called a square, but he wouldn't have had access to that sort of a tool. So think about some way that he could make the columns straight using the materials he would have access to. When he got home, his father was talking about his ship. "I sailed to Crete with a shipload of tiles, but Leopus and Boundus got there before me. With their fast new ship, they will take away all my customers." Through a mouthful of bread and olives, Pythagoras asked, "Father, you always sail to Rhodes first and then to Crete. Why don't you just sail straight from here to Crete? It would be a lot faster." "It's too dangerous," his father replied. "It would not be safe to sail straight from here to Crete unless I knew the exact distance. Out at sea, I could miss Crete and end up anywhere. I'm leaving for Egypt tomorrow. I want you to come with me, son. One day you will command my merchant ships, and you have much to learn." At dawn the next morning, Pythagoras and his father set sail. As they sailed along the coast, Pythagoras said, "I can't wait to see Alexandria. I hear they have great buildings there. I might want to be a builder some day." "But son, you are going to be a merchant," his father said. The life of a merchant is exciting. You get to sail to faraway places." He put an arm around Pythagoras' shoulder. "You just have to look at it from the right angle." Soon they were sailing into the port of Alexandria, the capital city of Egypt. Pythagoras marveled at the great lighthouse that stood proudly against the sky. "Saltos and Prepros should see this," he exclaimed. At the dock a man greeted them. "I am the builder, Neferhepper Housekeeper, but people call me Neph. I'm here for the tiles." Pythagoras was excited to meet a real builder. "Have you built anything around here?" he asked. Neph nodded. "As a matter of fact, I helped to build the lighthouse." "How did you get the base so straight?" Pythagoras asked, thinking of the crooked columns back at home. "You must be a master builder." Neph smiled and stuck out his chest. "The secret is this special rope that's been used by my family for ages." "You use a knotted rope to cut stone?" Pythagoras asked. Neph laughed. "My dear boy, this rope does not cut stone. I use the rope to make a special triangle. It's called the right triangle because it helps me make a nice square corner that's exactly the right angle for cutting stone." Neph let Pythagoras hold the rope. Pythagoras made some triangles, but none had the right angle. "How long do you make each side?" he asked. "Oh, I've shown you too much already," chuckled Neph, as he took back his rope. "Why don't you run along now?" "What do you notice about the knots?" What about the spacing of the knots on each triangle? What about the triangle themselves? There appears to be 12 knots in the rope. And I notice that the spacing between the knots is the same in both ropes, and is in the same between each knot. Neither of these triangles form right angles. Can you find a way to make a right triangle with a rope knot on each corner? How long is each side of the right triangle? I have already created it, but there are others that we can make by dragging the sides to form right triangles. You get to move both of these. I have sides 3, 1, 2, 3, 4, and this side is 1, 2, 3, 4, 5 sections long. Once other students have completed this activity, additional triangles will show up here. They will also be 3, 4, 5 triangles, but they might be oriented a little differently, like turned around or flipped upside down. As his father and Neph talked, Pythagoras found an old piece of rope and tied knots in it. He pulled the rope into different triangles. Finally, he made a triangle that seemed right. It had 3 lengths on one side, 4 lengths on another side, and 5 lengths on the longest side. I've got it, he said to himself. Just then Pythagoras' father called him. Carry this crate of tiles, son. Neph and I will carry the rest. I would carry them, Neph sighed, but I've hurt my thumb, so I can't. You'll have to make 2 trips. When they got to the house Neph was building, he said, While you get the rest of the tiles, I'll get the money I owe you. Grumbling, Pythagoras' father headed back to the ship. Neph patted Pythagoras on the head. Be a good boy and watch these tiles for me, he said as he disappeared into the house, and don't touch anything. Pythagoras looked around the sunny courtyard. In the middle stood a statue base made of stone. He took some tiles out of the crate, just to see how they would look around the base. I can put them back quickly, he thought. He made a row of 3 tiles along one side of the statue base. He added 2 more rows of red tiles, making a square. Pythagoras made 1 small square with red tiles and 1 medium square with blue tiles. If he started moving these tiles into a 3rd square, how many tiles do you think would fit? Our triangle was 3 sections by 4 sections by 5 sections. So if we made a 5 by 5 triangle, that would require 25 tiles. Try it yourself. What do you notice? What do you wonder? I notice that it uses all of the tiles from the other 2 sides. And I wonder if this would work if we created a larger base triangle. Some of the crates have blue tiles, Pythagoras said. Soon red and blue tiles were scattered everywhere. Pythagoras made a square of blue tiles and a big square of red and blue tiles. He was admiring his work when he noticed. This statue base is a right triangle. Its sides are 3, 4, and 5 tiles long. He counted the tiles. Strange, he thought. The 9 tiles in the red square plus the 16 tiles in the blue square equal 25 tiles. There are exactly 25 tiles in the big red and blue square. Suddenly a voice demanded, What do you think you are doing? Neph rushed into the courtyard. Pythagoras' father was right behind him. What's all this? Neph snapped. I'm sorry, Pythagoras said. I was going to put the tiles back, but I found out something interesting. I don't care what you found, interrupted Neph. Look at this mess. Pythagoras, pick up the tiles, his father said sternly. And hurry, we have many more stops to make today." The next day, Pythagoras and his father set sail for home. To pass the time, Pythagoras drew a picture of the tile squares he had made. The square with 3 tiles on each side had 9 tiles. The one with 4 on each side had 16 tiles, and the one with 5 on each side had 25 tiles. So in a square, the length of a side times itself is the number of tiles in the whole square. I'll call it squaring. When I multiply a number by itself, 3 times 3 is 3 squared. I'll write it 3 to the second power. And you can see here at the bottom, 3 squared is 9, 4 squared is 16, and 5 squared is 25. What if the third side length were not 5 units? Would the red and blue tiles fit exactly into the third square? If we drag these in here, is it going to fit perfectly? Nope. What if I made it smaller than 5? In this one, I have leftovers. So if the third side length were not 5 units, would the red and blue tiles fit exactly in the third square? No. If it is less than 5, we have too many tiles. If it is more than 5, we do not have enough tiles. What do you notice about the angle when you try a third side length other than 5 units? If I make it smaller, I get an acute angle. But if I make it larger, I get what's called an obtuse angle. Pythagoras drew a new picture. 3 squared plus 4 squared equals 5 squared, he said to himself. I wonder if the squares on the sides of other right triangles add up the same way, he thought. Pythagoras practically flew off the ship when he got home. He couldn't wait to tell Saltos and Pepros about the special knotted rope and the secret of the right triangle. When he got to the unfinished temple, Saltus and Pepros were not there. The ladder was on the ground where Pepros had thrown it. That ladder would be easy to climb if the bottom were about 5 feet away from the wall, Pythagoras thought. Pepros said that the wall is 12 feet high. How long do you think the ladder should be to reach exactly to the top of the temple? Now, this is a prediction at this point. This is an estimate. We know that it needs to be longer than 12. If we made it 12 plus 5, that might be too long. So somewhere between 12 and 17 feet. I'm going to approximate it to be 14 feet. It looks like it's a little too long. So let's try 13. That looks pretty spot on. When he got to the unfinished temple, Saltus and Pepros were not there. The ladder was on the ground where Pepros had thrown it. The ladder would be easy to climb if the bottom were about 5 feet from the wall, Pythagoras thought. Pepros said the wall is 12 feet high. He drew a triangle in the dirt and wrote, 5 squared plus 12 squared equals something. Well, 5 squared is 25, and 12 squared is 144. 25 plus 144 is 169, which is the same as 13 times 13. That's it. The ladder needs to be 13 feet long. He fixed the ladder and headed home. At home, Pythagoras got out a map. He looked at it closely. I wonder, he said to himself. That night, Pythagoras announced, I found out the distance from here to Crete. His father nearly choked on a fig. His mother asked, How can that be, son? Pythagoras answered, I discovered a pattern that works for any right triangle. I used it to figure out the distance. Now father can sail straight from here to Crete. His father stood up. Son, I cannot risk my ship because of some triangle. Father, Pythagoras started to explain. At that moment, Saltus and Pepros came rushing in, puffing hard, as if they had raced up the hill. Pepros turned to Pythagoras. You did something to our ladder. Has Pythagoras been bothering you again? His father asked, frowning. Saltus shook his head. No, he made our ladder the perfect length. We will be able to finish the roof now. Pepros added, Then all we'll have to do is fix the crooked base of the column. Maybe I can help, Pythagoras offered. Use my rope to make right angles. If you use a right angle to make the base straight, the columns will stand straight. Saltus laughed. Great, now we can finish the temple on time. You're welcome to stop by and help us any time you like. Pythagoras' father said, Son, on second thought, maybe you should tell me about the distance to Crete. Pythagoras explained, Our island, Samos, forms a right triangle with roads in Crete. If I call the sides of the triangle A, B, and C, I can use my right triangle pattern, A squared plus B squared equals C squared, to figure out the distance from here to Crete. You can see how A squared plus B squared equals 34,225. To find C, the distance between here and Crete, I had to find what number multiplied by itself equals 34,225. I already knew 148 squared is 21,904. That's too small. I tried 200, but 200 squared equals 40,000. That's too big. I tried 180, and 180 squared equals 32,400. That's close. Then I tried 185 times 185. That's exactly 34,225. So the distance from our island to Crete is 185 miles. You can see in his picture, he has from Crete to Rhodes is 148, so he squared that. And from Rhodes to Samos was 111, so he squared that. So square the two values, then add them together. And you have to figure out what multiplied by itself would give you that answer. You can see how A squared plus B squared equals 34,225. What do you think the distance from Samos? What do you think is the distance from Samos to Crete? It told us in the last slide that 185 squared is 34,225. So let's try 185. And it looks like the ship made it. Then I tried 185 times 185. That's exactly 34,225. So the distance from our island to Crete is 185 miles. Everyone was amazed. Pythagoras' father clapped him on the back. Good thinking, son. You'll make a fine merchant some day." Pythagoras' mother said gently, "Perhaps he can use his quick mind for other things." His father nodded. "Son, with your clear thinking, you could be a general, a senator, a teacher, or anything you want. It's your choice." Pythagoras smiled. He hoped to do great things in the future. A few days later, Pythagoras saw his father's boat sailing into the harbor. His father ran to greet him. "Pythagoras, you were right. I made it to Crete in record time," his father said, hugging him. Pythagoras looked up at his father and said, "You were right too. I just had to learn how to look at things from the right angle." And then here's a little historical note on the Pythagorean theorem.